Okay, last section of this chapter. So, steps for proving triangles congruent. Write down your given information. We've done this before. Mark the congruent parts on the diagram. Write down any information you know from the given. Example, is something bisected? What do you think are congruent because of it? Write anything using the reflexive property, common sides, angles, or vertical angles. Then use our rules to prove them congruent, and use CP/CTC to prove corresponding parts of the triangles congruent. So, given that KM bisects JML, we know those two angles are equal. And J is congruent to L. We also know that this is equal to itself. Well, if we can prove these two triangles congruent by angle, angle, side, right here, angle, angle, side, then we can prove the parts JM and LM congruent. So let's do that. Again, we write KM bisects angle JML. And angle J is congruent to angle L. And that's all given to us. Now, based on the bisecting, we know that angle JMK is congruent to angle LMK. We keep the order the same. And that would be definition of angle bisector. We also know that MK is congruent to itself by the reflexive property. We now can prove that JMK, triangle JMK, is congruent to triangle LMK by AAS. And then we can say that line segment JM is congruent to line segment LM by CPCTC. Remember, hit pause if you need to. Okay, so we know that F is congruent to J. We're told that FH is congruent to GJ. If those are parallel lines, we know we have alternate interior angles here. You may want to turn your paper sideways to help you visualize that. And we know that this line is congruent to itself. Oh, I have two ones, so I think I'm going to make this 3. And remember, I cannot use angle, 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 because that's not a rule. But I can use angle, side, angle. I could also, if I wanted to, use angle, angle, side. Either one works. So I'm going to start up here. Reason. Angle F is congruent to angle J. And FH is parallel to GJ. Given. Now, we said that GH was congruent to itself by the reflexive property. also said that FGH, angle FGH, was congruent to, now be careful here, we're starting at 3 arc marks, going to 2, going to 1. So that means I'm going to go JHG, 3, 2, 1. Angle JHG. And it makes sense because here G is in the middle and it has 2 marks, and here H is in the middle and it has 2 marks. Now, depending on which rule I go with, I may need the other angles. So I'm going to say also angle FHG is congruent to, I started at 3, went to 1, so that's JGH, angle JGH. And both of these are the same rule. If lines are parallel, alternate interior angles are congruent. Now, I can prove my triangle's congruent. Triangle, I'm going to go 3, 2, 1 again. FGH is congruent to JHG, triangle, JHG. And I can use either rule. Let's go with angle, side angle this time. And now at this point, I can say that line segment FH is congruent to line segment JG by CPCTC. Corresponding parts, congruent triangles are congruent. Okay, CD is perpendicular to AB, which means this is 90 and this is 90. D is the midpoint of AB, which means those are equal. DC is equal to itself, so we have side, angle, side. I'm just going to extend the page here. You can write it wherever you have space. So again, our given is CD is perpendicular to AB. Also, D is the midpoint of AB. Given. What did we mark? Well, we said that AD is congruent to BD, mind your order. And that's the definition of a midpoint. We also said that CD is congruent to itself. And that's a reflexive property. Then we need to say that CDA, angle CDA, is congruent to angle CDB. And that's the definition of perpendicular lines. They intersect a 90-degree angle. And now we can say the triangle CDA is congruent to triangle CDB, ISAS. And now we can prove that CA is congruent to CB by CPCTC. Again, hit pause if you need to. Now, when you have something like this, it might help you to pull them apart. mean that. Z goes here. This is W. Y. So YWZ right here is congruent to XZW. And YZW so YZW right here is congruent to XWZ right here. Notice WZ is WZ, so that's the reflexive property. Now this one's a little more challenging. So notice we have this angle here and this angle here. Okay? So that helps you if you think about it, by pulling it apart, you can see it a little bit better that we have angle, side, angle. When they're overlapping like that, it's kind of hard to see. But if you can pull them apart and separate them and mark them, you will see that you have the information you need to call them congruent. I'm going to extend the page here. So these overlapping pictures sometimes helps to do this. So YWZ is congruent to XZW. Angle XZW. And YZW is congruent to angle XWZ. And that's given. Then we just say that WZ is congruent to itself by the reflexive property. And now we have enough information to say triangle YWZ is congruent to triangle XZW by SAS. At this point, we can prove WX is congruent to ZY by CPCTC. Okay, so again, might help to draw this out. CAB ABD, like so. And mark. It says CA and BD are the same. CA, BD. CA, BD. And CB and AD. prove that C and D are equal to each other. And then AB is obviously equal to itself. And so now we'll be able to prove these congruent by side, side, side. So CA is congruent to BD, and CB is congruent to AD. And that's given. So there's two of our sides right there. Then we say that AB is congruent to itself by the reflexive property. Once we've proven them, all three parts, we can now say that ABC, triangle ABC, is congruent to triangle, and you gotta be careful of the order. So we went out highway 3, down highway 2. So BAD. And that's by SSS. And now we can prove that angle C is congruent to angle D by CPCDC. You can hit pause if you need it. Now here we have a challenge problem. Okay, so this will be fun. QR congruent to RW. And TR is congruent to RU. I would actually say UR. That's a QR and WR. Just to keep it in our heads, the order. Keep it proper. When we name these triangles, it works out. And we know that those two are equal to one another. Okay, so this one is really challenging, so just go with me on this one. So we have all the information to be able to prove this triangle congruent to this triangle by SAS. Okay, so let's just do that, then we'll come back to the continuing part, because I'm going to want to erase stuff. So, again, given QR congruent to WR, and given TR is congruent to UT, given. And then we said, we mark on our triangles, that TRQ is congruent to URN. That's a definition of vertical angles. Now, once we have that, we can say the triangle TRQ is congruent to triangle URN by SAS. Now, once we know those are congruent, we can come in up here and say this angle is congruent to this angle. Of course, I made a mistake. It's not URN, it's URW. Sorry. So at this point, I can say that angle Q is congruent to angle W. Oh, I know why. in your packets, I believe this is an N. There's my error. I was looking at the packet also. So let's just go with what's in your packets. So let's go back to saying this is N. And we can say that by CPCTC. Now, why do we want those angles congruent? Well, come back with me, and I'm going to kind of do some erasing and clean this up. Now, we know that this angle is congruent to this angle. And we know this line is congruent to this line. Well, if we imagine TU is not there, and kind of erase it, we have a congruent angle right there, don't we? By vertical angles. So we can say that QRV, right here, this angle, is congruent to SUN. And we're going to write that right here. And hopefully you can see where we're going with this. Angle QRV is congruent to angle NRS. Now we just got to say the Q and N were the same, so we got to go in the opposite order. And that's again definition of vertical angles. Now, what we're going to do is we're going to prove that by angle, side, angle, our new angle here, that this triangle is congruent to this triangle by angle, side, angle. See what we just did there? So now we just say triangle QRV is congruent to triangle NRS by ASA. And once we do that, we prove the two bigger triangles. Now we can go back and say that VR is congruent to SR by CPCTC again. So that's why it's a challenge, because we had to prove smaller triangles congruent, then CPCTC, then go back and prove the bigger parts using the new information we got from the smaller parts.